Hey YouTube, this video is on the installation of a Hobbyeagle Super 2 gyro along with a FRSKY L9R receiver and a Taranis radio. And obviously I've already got it plugged in and working, so I'm not going to do a full unbox, but I am going to show you the wiring diagram. I will show you the software configuration, and I will show you the Taranis configuration so you can get yours up and running easily on this type of setup. So I'm using, again, a FRSKY L9R receiver. I like these, even though they don't have telemetry in a park, because they're designed for range. And when you're park flying, you really don't get that far away. And I'm assured with this receiver that I shouldn't have any issues flying around in the park and losing connections. So even though I'm not getting things like RSSI and the Taranis, I'm okay with that because I've personally flown these receivers out a lot farther than what I would do at, say, a park. So anyway, let's just jump right into the wiring. So first thing I'll do is cover the wiring, and after that I'll go through the software configuration and how to set up the controller itself in software. And then when we're done with that, we'll plug in the Taranis radio and I'll show you how to configure the Taranis to make it work. Okay, so right off the bat, you might notice this capacitor. The kit actually comes with that, and I'm a big fan of these. I actually use these on some of my other airplanes, like my long-range FPV, and all this does is helps prevent against a power brownout. So if for some reason one of the devices in the chain from the battery, there it is, from the battery to the receiver to the stabilizer, if there's a brownout situation, the capacitor just helps keep the voltage up to 5 volts so you don't lose or you don't see a reboot on one of the devices. Okay, so in terms of the wiring, it's real simple. On the controller, you'll see that there's an S.Bus or mod cable, and then there's out 1, 2, and 3. Real simple wiring. This S.Bus cable, what I connected that to on the L9R is, and sorry, you're going to hear some jittering because the battery's on and I've got it in stabilized mode. So anytime the stabilizer moves, the servos are going to move. But anyway, you can see on the L9R there's an S.Bus connection. That's the bottom right there. That's that 3-wire plug on the bottom. That's the one, the 3-wire plug that goes into the S.Bus/mod channel on the Hobbyeagle. And that's all you need for the control surfaces. Now keep in mind, on this plane, obviously there's an ESC and gear. So that's why there's still a couple of connections left on the radio. One of the connections is the capacitor. And remember, this is sharing a 5 volts across the S.Bus wire. So that's where the Hobbyeagle is getting its powers, from the ESC. So we have one connection that's the capacitor. That's right here. And you can plug it into any open port, it doesn't matter. Then the next connection I still have on here is my, let's see, that is going to be landing gear on number 5. And then the last one that I have is the ESC, and I have that on channel 3. Now, that was the basic setup I had before I installed the Hobbyeagle. I had ailerons on 1, elevator on 2, throttle on 3, rudder on 4, gear on 5. So all I did was removed the aileron, elevator, and rudder. All right, that's all the Hobbyeagle needs to see. That's all any stabilizer really needs to see, unless you're flying a full-on flight computer that's going to control your throttle for you. Now, those channels from a signal perspective are now sent over the S.Bus connection, which is down here on the bottom of the L9R. All right, just one more look at it. That's the bottom. It's kind of hard to see, but there's a good look at it. It's kind of sideways compared to what you normally see. And notice on this one, the orange is inboard and the ground is outboard. All right. Now, on the Hobbyeagle, the only connection it has from the receiver is right there, the S.Bus connection. That's it. The rest of these are documented in the book, but out 1 goes to the ailerons, out 2 goes to the elevator, and out 3 goes to the rudder. Those are the servo wires. So basically, the servo wires come off of here and get put onto here, and you add this S.Bus link right here to the bottom channel on the L9R. And that's it. That's all you have to do. Now, real quick, because I'm going to be doing this in different parts, I'm just going to show you the mode switch. So right now I've got it in stabilized mode, and these codes are in the book. They'll give you color codes in the guide that tell you what the different LED colors mean. So red is everything's off. So this is straight up connectivity, you know, directly to the surfaces. The stabilizer is not interfering. If I move the stabilizer around, nothing happens. So that's off. The second mode is what they call normal mode, or blue. And what that's for is wind rejection. So this is kind of like the Taranis $11 stabilizers I was telling you about. That's just for wind rejection or gyro mode, and that's it. And then the last mode that I configured was auto mode. And the idea behind this one, this actually should be able to save the plane. If you have a problem, you can flip it into auto mode and it should get the plane flying straight and level. But they also call it a beginner's mode or an FPV mode. So the idea is the plane will fly straight and level in this mode. Okay, and then the last thing you can't see because there's no real connection for it, but we'll cover it in the radio, is the gain setting, and I have that set up on a knob. But we'll get into that when we get into the radio configuration and the software configuration for the Hobbyeagle. Okay, so that's the wiring. Real simple wiring. There's nothing to it. It just took me a few minutes. So next we'll get into the software, and then after the software, we'll break out the Taranis and I'll show you what that configuration looks like. Okay guys, here's the Hobbyeagle software, and you can download this on the Hobbyeagle website. It's really easy to find it. Just Google Hobbyeagle Super 3 or Super 2, and Google will take you right to their home page where you can download the software for this. Once you get it installed, you're going to need to actually, I'm going to have to unplug and replug because mine's already talking, but I want to show you real quick how to get the driver going. So you'll see when you first connect it, you'll see this. Now, oh, by the way, it does come with this cable. The newer cables have that, I think that's a FRSKY adapter, and it's encased in plastic, but the Hobbyeagle unit does come with the cable you need for your PC, so you don't have to worry about buying anything extra. But once you plug it in, you'll see a request to load a driver. Now, again, I've already installed mine, so I don't have to go through it, but you just click this USB driver and it'll bring up a hardware driver dialog box, and you just kind of go through that and let it install. I didn't have any problems with this. It was virtually automatic. I just hit yes and let it install, and then once I did that, I saw the Silicon Labs CP210X USB to UART, and I selected OK, and as soon as I did that, you'll see I got down here data read successfully. After that, you can turn it in debug mode, and you'll get a look that you should be able to see that when I'm moving the gyro right now, or the unit on the airplane, you should see it move like that. So you'll see the gyro pitch roll and yaw and what's going on with the accelerometers inside. You just click on debug mode. Okay, so the first thing you do is you choose your flight modes, and what I always like a gyro off because I don't necessarily always trust these things, so I always want a switch that lets me just turn it off, and that's my upper position on my radio. The second position is basically wind rejection, so I'll turn that on and see how it does, and I'll check the gain and make sure we've got good gain settings so it's not getting too jittery. And then the last section is auto balance, and this might be fun if you're maybe racing some laps or you just want to cruise around real fast. You can put it in auto balance mode and it'll maintain. Now, there's no GPS, there's no barometer or anything like that. Its ability to maintain altitude is going to be highly dependent on whether or not you set level correctly on the airplane. But anyway, the point is that this just kind of takes some workload off the pilot. And when we fly FPV long range, I often use a 2D hold mode, which does actually maintain altitude because it's got a barometer and a GPS and it knows how high it is. So anyway, auto balance mode, the idea behind that one is straight and level, and this is the chicken switch. So if you get into trouble while you're flying, theoretically, you can put it in auto balance mode and it'll fly straight and level. So all I did on the basic tab was set the modes that I wanted. I left the response rate and the frequency alone. I didn't do any user-defined modes. This is a nice little feature of this particular software. Is you can select one of these flight modes to be user-defined, like that one, and in that one you can say, well, I just wanted to keep the elevator from flopping around, or I just wanted to keep the elevator and the aileron but no rudder, or whatever. So kind of cool, a little bit of flexibility you don't see in the cheaper units like the Turnigy. I like that, but I'm not going to use it. And then on the bottom, we'll get into that later, but when you set it up and turn on the stabilizer, of course you want your radio working before you do any of this, right? But once you connect the stabilizer, you have to make sure that the stabilizer reacts correctly to movement of the airplane. If it's not, you can reverse any one of these surfaces. So aileron, elevator, and rudder, you can reverse those. And then you'll also notice, this is another nice feature of this one, it's got aileron 2 and elevator 2, which means if you had two different servos and two different channels on your radio for the aileron and or elevator, you can activate both those on the stabilizer as well, which is really cool. That's kind of an advanced feature. I only have a very few number of airplanes that do that. I have a Escapade MX, and I do that because that plane really needs flaperons. It comes in real hot without them, so I set up 2 channels for the ailerons, and I do flaperons, and that's why I use that. But bigger planes might need something like that, and in fact, an FPV plane, it's not necessarily a bad idea for a long-range plane to have 2 elevator servos in case one fails. So anyway, nice little feature. I thought that was a pretty cool capability for a basic flight stabilizer that's not a full-on flight computer. Okay, wing type, obviously 3 choices: standard, a Delta, and a VTAL. This plane, it's a Hellcat, so I just chose standard. I didn't get into the configuration for VTAL or Delta, but my guess is, if it's like any other computer I've ever used, you configure the radio as a standard airplane and you let the stabilizer do the mixing. That's how you do it on things like the Vector. My guess is probably something similar with this computer or this stabilizer. This is a real surprise. I was really shocked at this. On the mounting tab, you get options on how you want to mount. This picture shows a straight, flat mount with the arrow pointing forward, but you can also do it upside down. You can do it upright, and that's actually kind of cool. I might actually be able to use that in the Hellcat, where it's basically standing on its side, and then there's upright inverted as well, which is the same thing but flipped around. For now, I'm going to leave it on flat, but very impressive feature set. I have, like, the Vector doesn't even do that. The Vector's a lot more expensive, and I know in the groups there's a lot of guys that kind of complain about that. Very cool feature. I was really surprised that they enabled that, and honestly, why not? It's just math. They just need to know which way the thing is pointing, and they can do the math from there. So very, very nice feature. I'm impressed with that. Okay, gain knob. You can see there. Oh, by the way, this stabilizer does other modes. There's 3D modes and auto hover mode. You can search on Google and check out the auto hover. It's kind of cool. There's like a one-click hover mode where you basically add gas and put it in hover mode, and all you have to do is manage throttle to keep it off the ground, and it'll maintain its own hover. I'm not into that kind of stuff, really. I've messed around with it a little bit, but it's not my thing, and it's definitely not going to be something I go through in this video. And then the 3D mode, similar concept, right? It'll help you hold a particular maneuver. So for example, if you want to do a knife edge, the theory goes you put it in 3D mode, you put it into a knife edge, let go of the sticks, and it'll keep that knife edge for you. So very, very cool features, I'd say. Gain rate, these are basically just multipliers on how much influence the control surface exerts with gain. I leave all mine on medium to start. I've never flown this one, so I don't know how it's going to react. But I do have a gain knob set up so I can dial the gain down on my radio, the overall master gain on my radio. I might come back and tweak that later, but I'll see how it flies first. Okay, now we get into the radio. This is really the meat and potatoes piece of it. Now, read the manual because there are a couple of different control modes. There's auto and manual. And in auto mode, you can either control the rate or the angle or the speed of the angle. Sorry, the speed of the surface deflection or the angle of the deflection. I'm not using any of that on mine. Might be something I'll tinker with later. It looks like a pretty cool feature, but for now, first flight out, I'm just going to leave it in manual mode. And what that means is that my radio directly controls the servos. If you put it in the rotation rate or the auto rate, the other mode, basically what happens is the stabilizer takes control of the servo output and it reacts and controls the output based on these specifications and what you do to the sticks. Okay, so that's enough of that. If you're interested in that kind of thing, you're probably more advanced on that type of feature than I am, so knock yourself out. I'm just putting mine in manual mode. Then in receiver type, here's the important part in terms of connecting to the L9R using S.Bus. You have to put this in S.Bus. S.Bus 2, I don't even know what that is. That might be a Futaba thing. Standard would be just PWM. So if you just wanted to do direct wire PWM, you could do that as well. I like S.Bus because it minimizes the number of wires I have inside. Okay, now here's the other key part. And then this is the part we'll match up to the radio. So you see I have on S.Bus channels. Now I was a little concerned whether or not I would have to put things like my ESC and my landing gear outside of the S.Bus stream, but I didn't have to do it. All I had to do is I basically left the aileron, elevator, and rudder just like I had it set up before. It's 1, 2, and 4. So that's how it was on the radio before I touched anything. Aileron was 1, elevator was 2, throttle was 3. You notice that's missing here. And then rudder is 4. So that configuration just carried over into the Hobbyeagle. And then I'm not using aileron 2 or elevator 2, so I set those to none. And then the only real changes I had to do to the Taranis, a lot like a Vector or the Turnigy or anything else that uses a computer, is I added a gain knob, and I used S2 for that. And I used a mode switch, and I used the SD switch for that on the Taranis. And that's it. So that's the radio configuration. Really pretty simple. I haven't done the level offset yet. I will. After I get everything mounted and fixed in the airplane, I'll do a level calibration and figure out if I need to set in an offset. Haven't done that part yet. I'll get to that at the very end. And then hover offset, this would be, I guess, if you're going to hover the airplane. Honestly, I didn't spend too much time on this tab because I'm not going to do that with this guy. And then there's an about tab with some links and email addresses. So before you configure anything, you have to hit the read button. It'll read the data. You make your changes. You set the modes to whatever you want. And then when you're done, you hit write. It'll ask if you want to save changes. You hit yes. And you should see at the bottom here, data saved successfully. That's it. Real simple. Not much to it on the... oh, got to put debug mode on if you want to see the gyro work. There it goes. Pretty simple, straightforward configuration. I'm kind of impressed. The software, I would say, once you kind of get over the idea of using software to configure a stabilizer, obviously with the Turnigy and other stabilizers I've used, it's just been a little tiny screwdriver and a gain knob. That's been about it. So the Super 2 by Hobbyeagle obviously has some more features. I'm really kind of curious to see how well it performs in the air. So that's it for the software. The next thing I'll do is break out Companion, and I'll show you the radio configuration on the Taranis. Alright guys, this is the final stage of the configuration of the Super 2 for the Hellcat that I installed it in. And what I've done is I've got Companion open and I've got my radio connected, and I'm just going to bring up the Hellcat configuration and jump right into the mixer. So basically the first 5 channels, that's what it was before I ever started. I didn't do anything to the first 5 channels. They're completely left alone, and that's what I started with. The only thing I added in order to get the gain mode or the gain switch working and the gain knob working and the flight modes working was I added on channel 7, I added the S2 knob with a weight of 100. And that dials the gain up and down. I forgot to show it in the Hobbyeagle software, but when you move that gain knob up and down, it does move the gain on that radio tab. It'll move the gain all the way from 0 all the way up to whatever it is, 1,000 or 1,200 or whatever it is on the software. So that's it. Simple. You just add a S2, call it gain, weight of 100, and you're pretty much done. I might mess around later with some logical switches to have it tell me where the gain is. I'll play with that later, but for now, just real simple. Right in the middle is half gain, so that's all I'm doing with that one. And then for the mode switch, again, super simple. All I did was I added a name called mode. I used source SD because I used the one next to it, the big one. I think it's SC for the gear. So I use SD. And then the switch is SD up. I don't think trim is really relevant. The curve isn't really relevant. And I left the weight at 100. So that's it. No warnings. Multiplex I used add. So then once I was done with that, I simply copied this and the only thing that changed on the next two, so I have SD as the source for the next two, the only thing that changed was the switch. I added switch minus, which is middle, and I added switch down, which is down. And that's it. Those are the only changes I had to make to the Taranis to get the gain mode working, or the gain knob working, and the flight mode switch working for the Hobbyeagle Super 2. Real simple, nothing to it. This is probably one of the easier upgrades I've done. I kind of expected this to take a little longer. What I was really worried about was, honestly, was the throttle and the gear being in the S.Bus stream, because as you can see, channel 3, the S.Bus stream is channels 1 through whatever you have the radio configured to send, 1 through 8 or 1 through 12. So I was kind of worried that channel 3 and channel 5 might be included in the S.Bus stream and wouldn't work, and I'd have to do something else, something unnatural. But it wasn't a problem. Basically, I just told the Hobbyeagle, as you saw in the software configuration, to ignore those two channels, and leaving them plugged into the PWM rail, they worked. They continue to work. So real easy configuration, and that's it. That's the Hobbyeagle Super 2. So the next video that I'll post on this will be a flight video. I hope to go out flying tomorrow, and I'll have a buddy there with me, and I'll ask him to film for me, but we'll try and put it through its paces a little bit and see how it does in the gyro mode or wind rejection mode and the auto balance mode. So that'll be the next video I put up. Anyway, hope this has been helpful. If it has, please, you know the drill, hit like and subscribe. That helps with my rankings on YouTube and gets these videos up a little bit higher when people are searching for this type of information. All right, thanks for watching.